Hello, I am Maxim. This is the first lesson of Funny Physics course. In this lesson, we will learn what is the momentum of the body and what is the law of conservation of momentum. But first, a disclaimer. If you hear that I pronounce words incorrectly somewhere, then write it in the comments where exactly I made mistake and how to say correctly. I am still learning English and your comments will help me a lot. And now to physics. What is the momentum? Momentum indicates how much movement object has. In other words, the momentum of the body will show us how much the object can repel another object. But what is the momentum? To understand this, we need some kind of moving object, such as a ball. Imagine how difficult it to catch and hold in your hands the ball that a friend slightly threw at you, and how much effort it takes to stop soccer ball flying after direct hit. What's the difference if the balls are same? The difference in speed with which the ball flies. The faster an object flies, the harder it's to stop. And now another example. Let's say you dropped a ball on your foot first, and then an anvil. In which case will it hurt more? The anvil will hit the leg harder. Also, if we drop it from same height as the ball, then it will be the same speed. The point is that the anvil has a large mass and it will more energy to stop it. So what do we have? The momentum is the greater its mass and the higher the speed. So let's write the formula. What else is worth knowing about momentum? That he can just appear or disappear. The momentum of body can be converted into momentum of another body or converted into thermal energy. For example, if we play billiard, we can see how when a moving ball hits a stationary one, it transfers some of the energy to it and stop or become slower. Or we drop anvil on the ground. Then we see how the anvil stops, and we see that the earth in this place is crumpled and slightly warmed up. In this lesson, we will analyze only the first process, the transformation to momentum. As I said, momentum doesn't appear or disappear. From the point of view mathematics, it means that if we consider two bodies before and after their interaction, then their total momentum will not change. Knowing this, we formulate the formula of the law of conservation of momentum. And now practice. Imagine that you are standing on very clean ice, in the perfect case. This means that in this exercise we will neglect the friction on the ice. And now let's calculate how many shots a Colt 9011 pistol need to fire at the target to accelerate our speed to 15 meters per second, which is about the speed 33.5 miles per hour. To solve the exercise, we will take the weight of person as 80 kilograms, and from the reference book we can find out that the mass of the Colt bullet is 14.7 gram and it flies out at speed 262 meters per second. To solve the exercise, consider the formula in our task. The role of the first body is played by bullet and the role of second body is played by person with Colt. Before the shot, the speed of both the bullet and the body is zero. That is, when we make shot, the bullet flies in the one direction and the body begin move to the another. So the total momentum is still zero, and we can transform the formula like this. Now we know that the momentum of body is equal to momentum of the bullet. Thus we know how much one shot repels us. And to find out how many shots need to be fired, we denote the number of shots as n. Now, we slightly transform the formula to get that to find the number of shots, we must take the body mass multiplied by speed we want to achieve and divide this all for mass and speed of one bullet. Substitute all values and get 311.5 shots. You can't make half of shot, so the answer is 312. Thank you for being with us. I have prepared several tasks as homework. For this you need to download our Subschool mobile application. The link is in the description, and inside the application go to the Funny Physics Open course. There you will find this lesson and mini outline and homework to consolidate the material from the lesson. See you soon!